Hello everyone. In this video what I'm going to show you is how you can print a table of a number till some certain number using recursion. So everybody knows how to do it with a for loop. It's quite simple, but not many people really get the concept of recursion, so they wouldn't be able to do it. But I'm going to help you do it. So I'm going to have two parameters in my function. Okay, and the first parameter is going to be the number itself, and the second parameter will be the number till we're counting. So for example, I want to print the table of 5. I'm going to put in 5 right here, and I'm going to say 5, the table of 5 till 12. So I'm going to put 12 there. So yeah, and then first I want to have an if statement. So in the if statement I'm going to see if num, actually not num, I'm going to put in this till. Okay, if it's equal to 0, because if it is equal to 0, then everybody knows what 5x0 is. It's obviously 0, so I don't want to print that out, so I'm just gonna return. Okay, I'm gonna terminate this function. Then we're gonna call the function itself, and I'm gonna pass inside of it number as the first parameter, and I'm gonna say till minus 1. Perfect. Minus 1. And then what I'm going to do is I'm going to put a big fat little cout, putting in the multiply, and then also whatever else comes, like the equal to and the endl. There's a lot that's going to come in here. Okay, because this is just something that I want to print out. So I'm going to say till multiplied by, what was it, number. Okay, and I'm going to say 5. So 5 would come over here, and 5x1, 5x2, 5x3, stuff like that. It's going to come over here, and the 5 itself is going to come in here. So I'm going to put num there. Now what this statement means basically is it's going to print out, it's going to see out like this 5, which is num, and then it's going to print out an x, and then it's going to print out the till would be like 1 equal to, and then it's going to multiply them. So then it's going to be 5x2, 5x3, 5x4, like that. So it's not going to print out 5x0 because we have this condition terminating. And let me explain this recursive nature of this. So number would be 5, till is going to be minus 1. So yeah, it's going to print in the ascending order, if you know what I mean. The way it's going to work is like this. If I put in, for example, let me just show you how this works. Run it, 5, and I'm going to print till 12. So let me compile, and if I run, you can see that it definitely gives us a beautiful looking table using recursion. Hope you like the video, but if you want to see how this works, then stay here. Otherwise you can, so like exit and close the video. So the way this works is like this. You're going to put in 5, we put in 5 here, and we put 12 there. So 5 is equal to 0, false, so it's going to come and call itself again. So there's one case where 5 is like that. Alright, then 5 is equal to num is equal to 5. Okay, well, num is always equal to 5, but I want to make it till. Okay, so till is equal to 5. Then the way this is going to work, sorry, till is equal to 1. Actually, so it's equal to 12, sorry. So this is equal to 12, and then I'm going to say minus 1. So now this is going to open up a new copy, and here it's going to be 11, and this is still running the 12 one. Okay, then 11 is going to check, is 11 here equal to 0? No. It's going to come over here and it's going to check again. It's going to call itself again, sorry. So now it's going to be 10, and I'm putting the dash next to it because the function hasn't completed yet, because it hasn't couted anything. So this is going to keep on going, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then it's going to check when. I'm just going to put in some dashes, some dots here to symbolize it's going to keep going, and it's going to come here till 1, and it's going to see 1 till is equal to 1, is 1 equal to 0, false, then it's going to call itself again, but in this time it's going to be equal to 0. Let me put a dash there also. Then it's going to see 0 is equal to 0, true, so it's going to pop. Okay, it's not going to call itself. It's not going to come over here to this line. Then it's going to come here 1, fine, and it's going to come over here to, it's going to come over here to 1, and then it's going to see out. So that's why you can see it starts at 5x1, because it's coming in the reverse order. 1, then it's going to go 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. As you can see, that's the order. So that's just how this recursion works. Thanks for watching.